In this video, we'll begin our discussion of section 2.1. This is solution curves without a solution. What that means is this is going to be our numerical way of finding solutions given a diffie-q. What does the diffie-q mean to help us out with that? This kind of method, there are full classes. I've taken a full class on something in this similar, like given me a data set, I can use that to find slopes. And then we went a little further and used data analysis to come up with an actual polynomial that represent things. But what this section is going to be is what are our rough ways of finding solutions. I could see this happening in meteorology. Now, meteorology is a little different with their vector fields, or what we're going to call direction fields here, because um, with wind and stuff, they change constantly. Anyway, okay. So what we're going to work on is called a directional field. A direction field. These are like, and I don't know, I don't want to write in blue if you've had your Calc 3 class yet, but it's like vector fields. Um, it's not exactly the same because it's not a bunch of vectors pushing us around. Um, like the path and the vector field are separate. They're two different things. While this thing doesn't have a vector field and a path, this is just a curve, but the curve is like our path, but it stays with the slopes. Okay, so what this is, if you guys haven't put this together, remember this is a slope. So actually, if I pick any x or y, it will give me the slope at that point. So like for instance, the point 1, 2, if I were to plug that in, dy dx at 1, 2, then I would get 1 squared plus 2 times 2 squared, 4, 8. So I think that's a 9. So that means at the point 1, 2, the slope is 9. I don't know anything else about it. So what we usually do is at that point 1, 2, 1, 2, we would put just a little slope there that represents slope 9, which is pretty steep. You're going to see I gave us a good handout, a clean way of looking at it. So, and we know the first derivatives represent slope of tangent lines, so we can just put it in the general form, which is exactly what you and I just did. Um, Here's the process, and we're going to do it on the next page. Make a graph filled with little lines that represent slopes at the points on the XY plane. Then, given a point, we'll find approximate solution curve. So let's go take a look. It's better just to jump into these. Okay, so I gave you guys this full chart on the left. When you have to do these are quite a bit of work. So it's best to be like everything else in this class. You'll hear me say a million times. Be neat, right? Make your work spaced out, because if not, it's going to look like trash here. All right, so the diffie here says to add R2. So I'm going to add X and Y. I made my chart here to match my grid so I could just go through and do it as we do it. So this is the 0, 0 plus 0. So I'm going to put a 0 here. It's just a flat line. Okay, 0 plus 1 is 1. I can fill these out. All right, so this is a slope of 1. And then I got to make them a little steeper as we go along. All right, and then going this way, got -1, -2, -3, -4. And those are going to be the same idea, except for negative. So it's getting a little steeper every time. It's really hard to do this with accuracy. As you can see, like I think my lines are looking pretty similar. But you just got to capture the idea that it's getting steeper as we go out like that. All right. We could also do it this way: -1, -2, -3, -4, and then 1, 2, 3, 4. So we know going up, they're all going to be negative, -1, and then steeper as we go up. Like I said, it's very hard to be accurate. And then positive here, positive, it's getting steeper. There we go. So we have that. And then we just got to fill in the rest. And this works like kind of nice the way, let me show you. Okay, so this is 1 plus, this is going to be -3, -2, -1, 0. So you guys can kind of see the pattern that's going to happen here. All right, so it's going to start at 0 way out here. And then it's just going to get steeper and steeper this way. Real steep. Right? And we can see that this is gonna happen like this. I don't know if you guys have picked up the pattern yet, but I'm gonna go ahead and fill them in. They kind of have this slant since we're just dealing with addition. There's a reason I just did a sum and not like a square or anything like that. -2s are in this diagonal. -1s are in this diagonal. And then zeros are in this diagonal. Wait, yeah, those are gonna be zeros. Overthought it for a moment. And then ones. and then twos, threes. So you can tell this is takes a while, takes a lot of work. So this isn't our best method. Most of the time going forward, you guys, if you ever had to use this method in your fields at all, you'll probably have a computer do this for you and it'll spit out a nice pretty picture. Okay, so that's what we have going through there. Oh, I didn't need this bottom row, I guess. Went out of my grid. There we go. We could have kept going if we wanted. So I'm going to do all my zeros first because those are easy. Nice flat lines. So those are all flat. And then I'm going to do my positive ones. It's kind of easier for me to kind of think the same slant the whole time. So there's one. Two is going to be a little steeper. And then three is going to be even more steep. And try to leave room for you to get steeper. Steeper on that diagonal. Then I'm going to go even steeper on that diagonal. And try to make it look like it's getting steeper. It's really hard here. So there we go. We can kind of see that it's getting steep there. And then you can kind of hear this one. Maybe it's better to go -1, -2, -3, -4, -5, -6, -7, and then -8 at the top. Maybe that's easier. 1, -1, -2, -3, -4, -5, -6. Getting real steep. Okay, then 0, 1, 2, -2, -3, -4, -5. It's real steep there. It's kind of hard. I think I probably should have like maybe slanted these just a little more to kind of show. Like I said, it's very tough when the slopes are like that. Maybe just make these a little flatter. And then 0, 1, 2, 3, 4. And then 0, -1, -2, 0, -1. And I think that's the whole thing. So what we did is this was our slope, right? We added every x and every y. The x's and y's matched up to my plane over here, right? These are 4s, where they're at. So this gives me a rough estimate of where things are going. Now, if I were to put little arrows on everything, it's kind of like a vector field, but it'd be missing magnitude. So it wouldn't tell me how much to push in that direction because this isn't like a vector field on a path or anything like that, or a path in a vector field. It's just a curve. Okay, so they say find the approximate solution. So I'm going to show you because you're not going to have bunch. You're going to have three or one solution for all three. These are all separate. So let's do this one in this orange. I don't know if you have colors, and it's okay if you don't. I'm going to do orange here. And then what we do is we follow the slopes. So, and there's slopes in between all these slopes. If we wanted to get technical, we could go into the 0.5s, 0.1s, and get a better and better estimate. So what this looks like it does is it's flat right here, and then it's just going to look like probably that's an asymptote. And then this thing curves and goes really steep, something like that. These aren't going to be perfect. I probably should have made that line a little, there we go. And then it kind of curves in real hard. Maybe like this. I'm never satisfied with these, by the way. It just doesn't ever feel great to me, but these are like super rough estimates. If I have you use something like this on an exam, it's going to be something I can actually grade, not like a line like this. I might have you match and make them very obvious. All right, we'll do the next one. It's red, starts at a different spot. So at -2, 2, there's my point. And then it goes up and it's going to do the same thing, right? Asymptote. And then this thing curves real hard going out that way. So you can see they're like the same shape. They should be the same shape, but I'm not a great, I don't draw well. So pink here. And then we have +4, 1. So it's right here this time. All right. Notice that these are going to get steeper. And it's kind of weird, but the slopes are slanting away. It may not feel like that, but they become steeper as we go down. So it's like kind of like this. I feel like maybe, or no, maybe like this. I don't know. It's really tough. So let's try to. This is going to slant up like that, and it does this like leveling out here on that line. And then if let's see if I were, these are all slanted this way, so it's going to definitely curve but it gets steeper. So I think it's something like that. So they look a little different. I think that one's going to be a bit off, but that actually emphasizes the point even better. These are very rough. The important part is having the slopes and using those maybe as your next how much do you go, and it uses a couple methods that you guys will learn um, in future classes. We don't go through the numerical methods in this course. If you're curious about why something like this would work, check out Euler's method, right? For diff EQs. So like I said, we won't do it in this course. It's really numerical heavy, but that's how they use data points like this to come up with curves. So, okay. So that would be it with slopes. I'm not going to do slope fields, direction fields. I don't feel like I need to do a bunch of them because they're so rough. You're just going to watch me draw a bunch of little lines and do my best with my sketchy stuff. If you would like on your homework, if you have to draw a vector field, use a calculator, or by calculator I mean computer. Go find a vector field, direction field calculator online, and you'll be able to type in x plus y, and they'll give you all these slopes. Print it if you want, screenshot it, do whatever you want if you would like to do that instead. I would challenge you at least to do it once because it just kind of shows how technical it can be. I always feel really bad and insecure about my curves here, but that's the best that they'll get. I think this thing probably takes, see, I'm still at it. I think it takes some kind of dip like that, but there we go.